Okay, so hopefully you've had at least a look at these other two examples and had a little think about the example that I showed you before. I'll talk these through now and you can see how much you got right or see if it makes any more sense seeing it a second time round. So we've got a different network over here, shown in the top left corner over here, and then now we've got it drawn in with the boxes that we need to fill in Dijkstra's algorithm. So remember, Dijkstra's algorithm, it is an algorithm. So an algorithm is like a list of instructions or rules that we follow in a certain order. And algorithms, we always follow the same structure in the same order. It's like a recipe for baking a cake. We always do the same things in the same order. And the advantage of algorithms is we can program a computer to do it. Now for Dijkstra's algorithm, of course, you're not going to have a person sitting behind a screen doing this like we are now. We're able to program a computer to do it for us, and this is how it will be used in practice in businesses and so on. A computer will be doing all this, working out the order, the shortest distances and so on. But the idea is that we're just following the same steps and processes that a computer would. We're just doing it, as a human. So it's always going to be the same thing we're doing. We're always going to start at our starting point. In this case it is A again, so be careful. It might not always be A. We can't assume it's always A. But we're looking here from going from A to J. Okay, we need to find the shortest path from A to J, stating the path and its length. So we're going to fill in all the boxes now using Dijkstra's algorithm. So if it hadn't been filled in already, we'd write a 1 in the middle box for A, because that means it's the first node that we're starting at. So it's the order in which we visit the vertices or nodes. And 0 means the distance we've travelled so far is always going to be 0 at the start. Now we look at all the branches coming off of A, all the places that we could potentially travel from A, and we can write in the working values box the distances that we could travel from A. So I could go to B in 18, I could go to C in 24, I could go to D in 35, I could go to E in 14, and I could go to F in 27. I could go to G in 33, there are loads here. Right, so these are all the ones I could travel to, and now I need to pick the shortest distance, the one with the shortest distance, which is the lowest number, obviously, and it's going to be E, because 14 is the shortest distance, it's the smallest number. So E is going to be number 2, and we can get there in a distance of 14. So those two numbers go in the box over there. Now we need to look at where we can travel to from E and double check, are any of those distances shorter than travelling directly from A? So from E I can get to F in 12. So the total distance there would be 14 plus 12, which is actually 26. So that's actually shorter than 27. So you don't have to cross out 27, but it makes it clearer that 26 is going to be actually the new sort of shortest path. We could also go to D in 20. So 14 plus 20 is 34, and that's also shorter actually, so I can cross out 35. I didn't do that on the last video, but you can do that to sort of make it clearer. Okay, we're now looking again at the shortest distance, and this is throughout the whole network. So travelling from A or E, where should we go to as our third vertex? Well, the smallest number actually is going to be 18, so it's going to be B. So B is going to be the third one we travel to, and we're going to go there via A, and it's going to be in 18. Okay, so next, where can we go to from B? We need to fill those in. So I could go from B to C, and that would be in a distance of 22, so it's shorter than going from A, so I'm going to cross that one out. And I could also go down to G as well. So I could get to G in 18 plus 10, so that's 28. So that's also faster than going directly from A. Let's now consider all the distances and find the shortest one. So the shortest one is actually 22. I think, yeah, the shortest sort of unvisited vertex distance is the 22 for C. So C is going to be number 4, and we're going to get there in a distance of 22. Actually, we could, as we go, we could sort of make a note on our diagram which arcs we're using to get those distances. So the 22 comes from going up to B and along to C. So I could just draw the line in there. And we got to E by going directly from A. Okay, now we need to consider where we can go to from C. Are there any new distances I can add? So actually I could go down from C to D in 10. So the total distance from A would be 22 plus 10, which is 32, which actually is shorter than the distance I had written before. So now where's the shortest vertex? It's going to be F at 26. So this is going to be number 5. And we're going there via E, if you recall. That was the 14 plus 12 gave us the 26. Right, and now from F I could go up to G, and that would be a distance of 26 plus 11, which would actually be 37. So it's not bigger, so I'm not going to consider that. I'll write it down. I could get to H in 24. I could go down to J in 34. So 26 plus 34 is going to be 60. Total distance of 60 to J. Or I could go take this path of 31 over to D. So 26 plus 31, that's not going to be smaller than 32, so I'm not actually going to write that down or consider it. Okay, so I've got to now look for where's the shortest distance on my diagram for all the nodes I haven't been to yet, which is the closest. It's going to be H, I believe, at 24. Where did that 24 come from? Actually, no, I think I was being silly there, because I put 24 because the length of this arc is 24, but it should be 26 plus 24 is the total distance away from A. So that's going to be actually 50. So actually it's not going to be that one. It's going to be, I believe, G, 28. Is that the nearest? It's going to be G next at 28. So that's going to be number 6. And the distance from A is 28. So remember, this distance, this 28 is the shortest distance of G from A. So this is where the algorithm is quite useful. We're trying to find the shortest path from A to J, but it's also going to help us find the shortest path to all the other nodes as well. And we got to G by taking this path along here, going from B to G in a distance of 10. So I can see that because 18 plus 10 is 28. So you can either remember that or just kind of inspect the diagram, figure it out. Okay, G is number 6 then, and I now need to consider if I can add any distances onto my diagram that might be shorter than the ones I already have. So, for example, going to H from G, that would be a total distance of 28 plus 20, which would be 48. So that's a little bit closer than going via F. And that's the only one I haven't been to yet. So that's all I can add there. So now I'm looking at H, D and J and seeing which is closest, which is going to be the next one, and it's going to be D. D is going to be number 7, and I can get there in a distance of 32. So that's by travelling down this arc over here, going from C to D, which has a distance of 10. So 22 plus 10 gives you your 32. And again, I need to consider, are there any places I can go to from D that I haven't been yet that are going to give me a shorter distance than the one I have in my workings box? So actually, if I go from D to J along this arc of 26, I'm going to get there in a distance of 58, which is a little bit closer than going via F, which I wrote down before. So I can get to J in a distance of 58. And there aren't any others that I can add, I don't think. So the only places I haven't been now are H and J. Well, H is going to be the next one that I label, number 8. And I can get there in a distance of 48. And that's going via this arc over here. And finally then, I can get from H, now that I've been to H, I can get from H to J in a distance of 8. So 48 plus 8 is going to give me 56, which is the shortest way to J I've found so far. So J is going to be number 9, and I can get there in a distance of 56 if I travel along this arc over here. So I've now completed the diagram. I now know that the shortest path from A to J is a distance of 56. So distance of 56. And the path is, if I just work backwards through the diagram, it's going to be going back up to H, through to G, up to B, and then down to A. So it's going to be going from A to B to G to H and then to J. So if I just draw this in for you, I can see that's going from A to B is going to be 18. Going from B to G adds 10, so that's now 28. Going down this path here gets me to 48 to H in sort of a distance of 48. And then adding 8 on gets me to my 56, which is the shortest way to get from A to J. Part B is a bit interesting because we haven't seen this yet. So now we want to know the shortest path from D to H via A, stating the path and its length. So D to H from via A. You know what, I think we'll leave that bit for next time, because let's just deal with going the general diagram and going from A to J in this case. I think that's enough for today. Okay, equally, let's ignore part B over here. Okay, let's just do the first part then. We'll look at the other parts in a future lesson, but I just want you to get the hang of the algorithm itself at first. That's the most important thing. So here was another example for you to try. Hopefully you've had a look at it. I'll now talk it through again. In the top right corner is the graph that or network that we're sort of basing this diagram on, and then you'll always have a working out diagram with all the boxes drawn in for you. Here we're going from A to H, so A is going to be number 1 and the total distance travelled at this point is going to be 0. And then we're just going through that process again, looking at where I can go and writing in the workings box how long it takes to get there. So I can go to B in 4, C in 9 and E in 14. The shortest of all of those is to go to B, so that's going to be number 2, and I can get there in a distance of 4. That would be travelling along this arc over here. From B, I need to add any new vertices that I can get to from B and their distances as well. So I can get to D from B in a distance of 10, so that would be in a total distance from A of 14. But that's not the closest. It's not the closest vertex. C is going to be the next one because the distance is 9. So that's going to be number 3, and the total distance is going to be 9. From C, I can get to E in a distance of 9 plus 3, which is 12. So that's quicker than going via or direct from A to E. And I can also go down to D in a distance of 2. So that's actually a total distance of A of 9 plus 2, which is 11. So that's also quicker than going via B. And from C, I could also get to F in a distance of 14. So let's write that in. But the shortest one that we haven't been to yet is going to be D. So that's going to be number 4, and we can get there in a distance of 11, and we get there going down this arc over here from C. Okay, from D, I can get up to F, but the total distance there would be 11 plus 10, so it's not going to be shorter than 14, so I'm not going to bother writing that in. I could also get to H in a distance of 16, which is going to be a total distance of 27 to get to H. There might be a quicker way, so I'm not going to go straight there. I'm going to see where's closest in the usual fashion. So which unlabeled vertex has the closest distance from A is going to be E, because 12 is the smallest number. So E, I'm going to label it with a 5 because it's the 5th vertex. I'm going to label, and the shortest distance from A is 12. From E, I can get back to F in a distance of 12 plus 8. That's 20. It's more than 14. So I'm not going to label that one. In fact, why is it saying 14? I think that might say 14. It shouldn't say 14, I don't think. I think perhaps that should say think perhaps I labelled it 14 because the arc says 14, and it should actually be 9 plus 14. Sorry, I did that again. So that should be actually 23, I believe. Unless 12 plus 8. But since that's the case, actually, now 12 plus 8 is closer. So actually I can get there in 20 by going via E. I can also get to G in total distance of 16. And that's all I can add for now. Yeah, so G is going to be the next one because the distance is 16. So I'm going to label that with a 6, and the total distance from A is going to be 16. So yeah, sorry, I'll just label this path here. So I got from C to E in 12 by going, I got from A to E in 12 by going down to C in a distance of 9 and up. That arc has a distance of 3. And I went to G along this arc over here, so it's quite good to keep labelling these on. Now from G, I can get down to F in a distance of 3. So the total distance from A, if I do that, is going to be 16 plus 3, which is 19. Or I could go down the arc to H, which is going to be in a total distance of 24. So that's quicker than 27, but F is still closer. So I'm going to label F next with a 7. Total distance from A of 19. And then finally, if I go along this arc of 4 from F to H, I can get there in a total distance of 23, which is the quickest or the shortest way so far out of all the paths. So yep, sorry, I went from G to F down here. So when I label H with an 8, the total distance from A, or the shortest distance from A, is going to be 23, and that's by travelling along this path from F to H over here. So the path that I follow is going to be from A to H. It's going to be, and then just working backwards in the diagram, well, I'm going to go use this arc over here from F to H. I'm going to be using this arc here to go back to G. I'm going to use this arc of a 4 to get back from G to E. Then I'm going to go down to C, and then I'm going to go up to A again. So I'm not going to use all the arcs that I've labelled because I just want to get from A to H. And if I look at all those arcs and I add them up, 9 plus 3, so the ones that I've highlighted, plus 4 plus 3 plus 4. That's going to give me the total distance of 23 that I'm looking for. So 3 plus 3 plus 4 is 10, plus 13 is 23. So that's just a check to myself. So the path is going to be the one I've highlighted. A, C, E, G, F, H. And the length is going to be 23. Okay, I'm going to add another example like this to the work for today that you can have a go at. Hopefully I'm going to be back on Friday, fingers crossed. So it should make more sense, or I can explain again when I'm back. Also, there are lots of resources online. So if you want to see a different explanation or to find more examples, I really encourage you to search it up on YouTube. There's a good channel called TL Maths, which has some more examples of this if you wish to see them. Or just drop me a message on Teams. Hopefully I'll be able to pick it up at some point and can give you some guidance. Okay, good luck.